Hello, everybody. I've had a large number of questions regarding Lesson 27. And this particular circuit starts at question number 6. And then, if I recall correctly, it goes on for like 9 questions afterwards. So there's a lot of people having some issues. So I went ahead and copied this onto my computer, and I'm going to and changed all the values. And we go through the solution on this for all 9 questions, just using these different values. So try to keep up, and of course you can back it up and go through your material, so hopefully it'll clarify any issues you're having. So first off, the question asks is, with the 3 amp load right here, the 2 amp load, and then your 4 1.5 amp loads here, what would be the current flow at this point on the black wire? Now, this all falls into Kirchhoff's second law. So, all right, so right here, you can see how this 3 amp load ties in with the rest of these loads going across the black. So this is definitely part of it. So all you have to do is basically start right here and work up and over counterclockwise from the point furthest from the load towards that source. So right here, if I've got 3 amps flowing in, I have to have 3 amps flowing out. Now once that comes to this junction right here, well, simply, I've got 3 amps from this load and then 2 amps here, so those two values are going to add up, giving you 5 amps at this location. Continuing on over, now I'm going to have at this junction another 1.5 amps added onto it, so that's going to be 5 plus 1.5, so that's going to be 6.5. Then, once you get to this location, 6.5 plus 1.5 is going to be 8. Here, 8 plus 1.5 will be 9.5. And then here, which will be the same as the value right there, it will be 9.5 plus 1.5, leaving you with 11 amps. Okay, so the black wire in this scenario will be 1.5 amps. Okay, now the next question asks you the same situation. Nothing has changed. It's asking you what's going to be on the red wire. So once again, I've got 3 amps. I'll be going more in a clockwise direction now. Once I cross this junction, it'll be 3 plus 1.5, so that'll be 4.5 amps. Cross this junction, 4.5 plus 2 will be 6.5 amps. Cross this junction right here, that current will add on to it, so 6.5. And I'm sorry I didn't identify that. I suppose I should say it. These are all 1.5 also. Alright, so that 6.5 plus 1.5 will give you 8. Cross this junction, 8.5 plus 1.5 will be, oops, sorry, trust me, I just do this for a living. 8 plus 1.5 is going to be 9.5. And then that's going to continue over this last junction point. 9.5 plus 1.5 will give you 11 once again. You'll see that something extremely similar is happening to the homework question. So the red, did I say 1.5 before? God, what an idiot. Sorry. The black was 11 amps. I apologize for that. And then the red is also 11 amps. Okay? So that should take care of, hopefully, showing you the method for figuring out the black on question number 6, the red on question number 7, and then on number 8, I believe, they're asking what's the load on the neutral going to be. Well, since the load is balanced, the two currents are going to cancel each other out, so it's going to be 0 amps. I know it asks to take it out to 2 decimal places, so if you're really that concerned about it, type in 0.00. But this is the answer for, well, extremely similar to the answer for number 8. Okay, so let me get rid of all this. Now, in the next question, what it states is that this load right here has been opened. So just imagine there's a break in the circuit right there. There is no 3 amp load. It really isn't any different. Instead, we're just going to start right here. So it's going to be 2 amps. To get to this junction, we're going to add 1.5 amps onto it. So 2 plus 1.5 is going to be 3.5. We get to this location, 3.5 plus 1.5 will be 5 amps. Keep moving over. 5 plus 1.5 is going to be 6.5. And then we end up right there, 6.5. Six 6.5 plus 1.5 is going to be 8. So our black conductor is going to have 8 amps on it. And another super easy way to do that would just simply to take the current we had last time, the 11 amps, and subtract off the 3 amp load as well. So that is your value for that black wire. You'll see that this is very similar to the solution to question number 9. Now, it's going to ask you the same scenario with this 3 amp load gone. What's going to be the current flow on your red? So we're going to start right here. Since this load here is gone, we'll be starting off with a 1.5 amp load. Then we'll add 2 amps onto it. And that's going to give us our 3.5. Here, our 3.5 plus our additional 1.5 amp load is going to be 5 amps. 5 amps plus another 1.5 is 6.5. And then we finish off right there with that last 1.5 amp load. So we have 6.5 plus 1.5. And we are at 8 amps once again. So the red is 8 amps. So one more time, because we took out this load that was shared across the two, we have simply just dropped our load 3 amps from 11 amps down to 8. We still do not have an unbalanced load, so our neutral is going to be 0 amps once again. Hopefully that's clear to everybody. So this would be question number 9, 10, and 11. Now, the last situation. They're saying that 2 of the lamps on the top circuit, we'll just say arbitrarily this one and this one. Whoa. Science. Okay. So arbitrarily, these 2 lamps are now burnt out. Our 3 amp load is active again, so we are going to start off right here, and we'll have our 3 amps. We'll continue over counterclockwise again. So right here, this current will add on to it, so that could be 2 plus 3, so that could be 5 amps. Continue on this direction. Add one more, or an amp and a half onto that, so it's going to be 6.5 amps. And then we get this lamp right here. One more amp and a half added onto it, so that's going to be 8 amps. We have no more current flow here because these 2 lamps are opened up, so our black is going to be done at 8 amps. Now, given that same scenario, we want to know what's going to be happening on the red. So we start off right off the bat once again with 3 amps. We add an amp and a half onto it, so that's going to be 4.5. Then we add 1 more or 2 more amps onto it, so that's going to be 6.5. An amp and a half onto that is going to be 8. Another amp and a half on top of that 8 will be 9.5. And then we finish up with our last 1.5 amp load, and we are once again back at 11 amps. So red is 11 amps. Now, so that should be question number 12 and 13. Make sure we got that right. Yeah, that should be right. So 12 and 13, our last question, number 14 asks, okay, with that same scenario with your 2 lamps burn out here and here, what would be the current flow on your neutral? Well, once again, the neutral carries the unbalanced load. So the neutral would be 11 minus 8. So in this scenario, it's going to be 3 amps. To say it one more time, what I have done is I took the exact same circuit that was out of your homework and I changed your values. In your homework, I believe this was 2, this was 1.67 here, this was 1, this was 1, and all the rest of these loads were 1.67 amps each. So you will have to change your math accordingly. I'm just going through the steps so you understand how it is done. Have fun with it.